Hello, class. Today our goal is to answer this question. On what intervals is this function x squared times 2 to the x increasing, and on what intervals is it decreasing? Okay. So that's going to give us an excuse to use our formulas here, as well as to make sure we can distinguish between x squared and 2 to the x, so we know which formula to use. I'll go ahead and use the magic of computers to pull up a graph for you of what this function looks like. So we're going to look at that as we go through and work on this problem. So let's start here by taking a derivative. And I should say before we take the derivative, our goal here is to use the first derivative test, because the first derivative test is our way of deciding whether a function's increasing or decreasing and where it's increasing and decreasing. Okay. So I go to take the derivative here. I'm going to need to use the product rule. So I'm going to get, and so the derivative of x squared, don't be confused, it is not related to the derivative of 2 to the x. It's still 2x. Okay. So that part has not changed. The only thing that's changed is now when I am given 2 to the x, I know the derivative is now the natural log of 2 times 2 to the x. That's our new formula. Okay. So really, this is the only new thing in the video. But stick around, it'll be fun. So we want to know what the critical numbers are, and you might look at the graph and try and guess beforehand where the critical numbers are. And so one of them appears to be at 0, and one of them appears to be at 3, just looking at the graph. Okay, again, those are the places where the tangent line is horizontal. Okay. But let's try and do this. So I'm going to set 0 equals 2x times 2 to the x plus natural log of 2 times x squared times 2 to the x. Okay, how am I going to solve this? Well, the way I'm going to solve this is going to be to factor. And so I have to look at what's in every term that I can factor out. Okay, well, there's definitely a 2 to the x in every term that I can factor out. But if you look, there's actually also an x in every term that I can factor out. So if I factor out a 2 to the x and an x, in this first term, I'm left with a 2. Plus, and in the second term, I'm left with a natural log of 2 and an x. Okay, so since I have this product of these three things being equal to 0, that means that it's only possible when one of these pieces is 0. Okay, so I need to solve 2 to the x equals 0. Okay, and this is one way in which 2 to the x works exactly like e to the x. 2 to the x is always positive, so there are no solutions here. Nothing to worry about. To solve the equation x equals 0, well, there we go. We solved it. Okay, so that means that our guessed critical number at x equals 0 was correct. It really was at x equals 0. Okay. Here, though, when we try and solve 2 plus the natural log of 2 times x equals 0, we're going to get natural log of 2 times x is equal to negative 2, so x is negative 2 divided by the natural log of 2. Okay. That is where my other critical number actually is. Okay. Now, as it happens, this number is fairly near minus 3, but it's not actually exactly minus 3. Okay, so then we can make our number line with our critical numbers. And so our critical numbers are minus 2, sorry, let me slide this up a bit, minus 2 over the log of 2, and 0. Okay. Notably, I know they're in that order. Okay. And so now I just have to decide, is it increasing or decreasing on each of these intervals? And so this interval corresponds to the first piece. It's increasing there. Then between this negative 2 over log 2 and 0, it's decreasing. And then from 0 onward, it's increasing. All right, and so What does that give me? Well, that gives me that it's increasing from 0 to minus 2 over log 2. It's decreasing from negative 2 over log 2 to 0, and it's increasing from 0 out to infinity. All right. We're going to wrap up there for today. Until next time.